Good afternoon, Physics Algebra 2 class. Getting to the end of the year, it's all kind of running together. Today we're going to be working on solving conical systems of equations. And there are a number of ways we could do this. We could solve this graphically, by substitution, by the addition method. We've talked about all of those methods with solving systems, and we're going to touch on at least some of them with working on solving systems of conical sections. So the first one I want to do is I want to just solve this by graphing. You know, kind of like where the two intersect is where the solution is. So this first equation here, I hope that maybe you could recognize this as a circle. It's x minus h squared plus y minus k squared equals r squared. And so that should sit there and go, oh, this is a circle. And maybe you're wondering, how do I know if it's a circle versus an ellipse? Well, in an ellipse, the coefficients of x and y will be different, whereas in the circle, they will be the same. So what we're going to do here is we're going to say that the center, the hk value for this equation is equal to 0, 0, and r squared equals 25, so r equals 5. You could go back if you want a more detailed explanation on how I came to those conclusions. You can go back to 14.1 where we spent a lot of time talking about that. So when it comes time to graph this, we're going to graph this in purple, so we know that this is the first equation. My center is at 0, 0, right there, and then I got a radius of 5, so I go up 5, left 5, down 5, and to the right 5. And then what I'm going to do is just going to, because I know it's circular, it's going to be kind of circular like that. And we've got our purple graph. Now, what we're going to do is we're going to take the second equation right here, and we're going to graph that. And we'll see that that's not a circle. It's not a parabola. It's not an ellipse. There's no squares in it. So yesterday when we were talking about the different types of conical sections, one of the things that we had was we had a cone. You're lying. And with the cone, we have a line that goes like that. So that not only is the circle a conic section, but the line is also a conic section. So if I were to put this into y equals mx plus b form, we take 2x minus y equals negative 2. And so we subtract 2x, negative y equals negative 2x minus 2. I want y to be positive, so I'm going to say y equals 2x plus 2. Just change all the signs, divide everything by negative 1. And so now when I graph that, my y-intercept, I know we're going back a ways. We haven't talked about graphing a line in a while. But hopefully you still remember y equals mx plus b. B value is 2, and then I go over 1, up 2, over 1 to the x, and up 2. If you don't know what I'm doing, let me spell it out for you. I start here, go over 1, up 2, over 1, up 2, over 1, up 2. And we could go the other direction. Back 1, down 2, back 1, down 2, back 1, down 2. Now, this just so happens that we see that there's solutions where it crosses. It's going to cross twice. It will cross the circle there and right there. So those are the two solutions. Now, remember, the problem with solving a system of equations, even if it's especially if it's a conical section like this, is that you don't get an exact answer. It's not going to be exact. Sometimes it is. Like I would say that this looks like it's a pretty exact answer, but then again, you don't know how circular I drew my graph, and so you can't usually 100% trust a system equation solved by graphing. But those answers should be pretty close. So I would approximate at -3, -4, and 1.5 over and 4.5 up as my solutions. Okay, where it crosses the two intersect. All right, let's keep moving. So, like I said just a moment ago, there is more than one way to solve a system. You can solve through graphing, you can solve through substitution, you can solve through the addition method. So, what I'd like to do here, first of all, is I'd like to solve these both by graphing them. So I'm going to make, again, just like last time, I'm going to make one purple and one green. So we'll take the first equation. We're going to say, oh, we're going to turn that one into our purple equation. We're going to put it in graphing form. Last slide I said circles have the same coefficient. You see how these ones have the leading coefficient of both x and y is different. Back when we talk about coefficients, students often say, oh yeah, coefficients, I understand the concept, but they remember it for like one day. And I think it's the easiest thing the first day, and they don't see how it can make a difference down the road. But here we can see in problems like this that it can really make a difference. So in this purple equation, because the coefficients are different, I'm going to say that this is an ellipse. And because it's an ellipse, I want it to equal 1. So what I'm going to do is I'm going to divide everything by 36. Divide by 36, divide by 36. So that reduces to 9x squared plus, sorry, not 9x squared, x squared over 9 plus y squared over 4. This reduces to 4, and that equals 1. I can graph that pretty simple. It's an ellipse, like I said, because they don't have the same coefficient. It's not r squared. And so I could go, the center of this is at 0, 0. I can go over 3 in the x, over 3 in the x, up 2 in the y, down 2 in the y. Connect the dots in a circular type of fashion so it looks like an egg. And there we go. Okay? So also, I'm going to have my green equation here. Again, I want it to equal 1. So what I'll do is I'll say x squared over 2, because I'm going to divide by 2, divide by, excuse me, got going a little too fast. I thought that was a 2y squared. As you can see in this particular case, this is x squared. I should have slowed down a little bit. This is x squared and this is just y. So that's not an ellipse. It's not a hyperbola, which is where I was going to kind of go thinking. I was like, oh, this is a hyperbola. No, this is actually a parabola. A parabola. And because it's a parabola, we can say we got the equation x squared minus 2y equals 2. So I can solve it for 2 by going, solving it for y, excuse me. So I'm going to say negative 2y equals negative x squared plus 2. Then we could say it's y equals 1/2 x squared, because a negative divided by a negative is a positive, minus 1. Now this is a parabola in graphing form. It's parabola. And it doesn't say anything about the focus and directrix. So on this lesson, unless it asks for focus or a directrix, don't worry about it, okay? So what I do now know is that at -1, I have the vertex. And I know it goes up and it's wide. So it's going to look something probably like this. Looks like a scary smile, doesn't it? Like it looks like you could put some eyes in there and you'd have a big scary smile, something like this. Ooh, that terrifying. Let's get that off the screen before we go any further. But anyways, the solution lies where x marks the spot. Not exact. If I want an exact answer, I have to do it mathematically, somehow using algebra. So what I'm going to do is I'm going to go back to the drawing board, so to say, and what I'm going to do is I'm going to say, actually, oh, I don't want to do that. I want to leave the inks on there for you. So I'm going to redo this in a blue over here, and I say that it's 4x squared plus 9y squared equals 36. And let's make that the red equation. X squared minus 2y equals 2. What I could do, and what I'm actually going to do, is I'm going to say I can solve for x squared. I say that's x squared equals 2y plus 2. The reason I do that is because I'm going to substitute that in to x squared in my blue equation. So what that looks like, I'm going to kind of start working down here, right here in this box. I'm going to continue my work. I'm going to say that's 4 times, instead of x squared, I'm going to write what x squared equals. 2y plus 2. And then I'm going to say plus 9y squared equals 36. So when it comes down to it, if I work this out, I get 8y plus 8 plus 9y squared equals 36. So now I can begin working on solving this by saying 9y squared plus 8y minus 28 equals 0. And from there, and for time's sake, no, let's just work it out. What we'd solve it with is the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So in red, we'll continue that. It's negative 8 plus or minus the square root of 64 minus 4 times 9 times negative 28 all over 2 times a is 18. Okay, that's 2 times 9. So now I get out my calculator, and I'm going to do 4 times 9 times negative 28. And I get negative 1,000 and, oh, excuse me, that's negative 4. So that should be 64 plus 1,008 under the radicand. Negative 8 plus or minus all over 18. So 1,008 plus 64, 1072. So negative 8 plus or minus 1072 over 18. So then I take the square root of that, and it doesn't come out pretty. It's not divisible by 9. I would just go with that. It's the answer. You could, get an approximation, because that's approximately negative 32. You could try to prime factor that down, because I'm thinking that 1072 is divisible by 4. Yep. So 4. So it's actually 4 square roots of 67. So our answer could be negative 8 plus or minus 4 square roots of 67 all over 18, which is all divisible by 2. So it would be negative 4 plus or minus 2 square roots of 67 over 9. Those would be the answers. That's the coordinates of that and that for x. And then you can plug that in to get into here. Well, no, that's the coordinates of y, isn't it? Yeah, y. So you can plug that in right here, and you can get x squared. But that would take a lot of time. Only do that if they ask you to, and they're only going to ask you to if it comes out immediately. I just wanted to show you how you can solve for those by substitution. Again, let me go back to this. This is If they ask for graphing, that's how you do it. If they ask for more exact, you got to go through this process. And sometimes that can be tricky. All right. Here's another one. Now this one, if I were to look at this, you have two parabolas. And I can solve them by graphing, substitution, or the addition method. Let's try the addition method to begin with. So let's just subtract the equations, because if we took y minus y, we get 0. 4 minus negative 2 would give us positive 6x squared. Negative 5 minus 3 is negative 8. This one's going to come out a lot nicer than the last one. So we're going to add 8, divide by 6. 8 over 6 equals x squared. So x equals positive or negative square root of 8 over 6. And if I were to do that, I'd say that x equals plus or minus the square root of 48 over 6. And 48 reduces to 4 root 3. So we can say x equals plus or minus 4 root 3 over 6, which will reduce to x equals 2 root 3 over 3. And that's plus or minus. And then you can plug that back in to get y. Again, I'm only looking for you to do that if it comes out neatly. The easiest way to do this is going to be solved by graphing. So I'm going to have a purple equation. And a green equation. We're going to graph them. So for the green one, I'm only doing that because I got the green out first. It's a parabola, and it's already in graphing form. So my vertex is at positive 3, and the parabola opens down, and it's narrow. Down and narrow. For the purple one, the graph is at negative 5, and it's up, and it's even narrower. All right, so the solutions arrive right there. Okay, that's how we solve systems. Here's another one. If we're working on this one, we got 2 ellipses, and let's start by graphing them. You could use substitution method, you could use the addition method. I honestly think that this one, graphing, is just going to be the easiest. Let's go with a purple equation. Remember, I want to equal 1, so I'm going to divide everything by 60. Divide by 60. Divide by 60. So I'll get 10 x squared over 10 plus y squared over 6 equals 1. That means my vertex is at 0, 0. That's kind of the nice thing about what we've encountered so far. But my x value, or my major axis, is going to be the square root of 10, which is approximately like 3.1. Let me try that exact. 10 is 3.1, 3.16. Okay, and then let's do this for the y. The minor axis equals the square root of 6, and the square root of 6 is equal to about 2.5, 2.4. So if I go in the y direction, 2 and a 4, and down 2.4, and in the x, 3.1 and 3.1, then I have my ellipse. Looks just like that. Now, on every graph that we've had so far, if I go back and I were to look at these, 2 solutions, 2 solutions, 2 solutions. This one, I'm not so sure it's going to have 2 solutions. It might, I don't know yet. But some of these equations might have 1 solution. Some might have 2 solutions. Some might have 4. In very rare cases, you're going to have 3 solutions. And you could have up to 4 solutions on these. So it's just wherever it crosses. So now let's work on the next one, the green equation. First thing I want to do is I want to divide everything by 64. Divide by 64, divide by 64. Nice thing about this is 16 times 4 is 64. It's almost like I probably set that up. So it would be x squared over 4 plus y squared over 16 equals 1. So the major axis, the change in x, is going to be positive or negative 2. And the minor axis is going to be 4. So 0, 0, again, is my center. No HK value. So x, I go over 2, and I go over 2. And then for the y, I go up 4, and I go down 4. Before I graph it, how many places is it going to touch? Right. All right. So it crosses in 4 different places. 1, 2, 3, 4. Let me mark them in a different color. X, 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 and X. All right, there we go. Looks like I got, is this the last one? Yep, last one. One more to do. So as I look at this, it looks like I've got an ellipse. I'm going to make purple and a straight line. So I want this to equal 1. Why do I know it's an ellipse? See how this is 9? See how this is 1? Different coefficients. It's a different coefficient. That means that it's an ellipse and not a circle. So I divide by 36, divide by 36, divide by 36. The first one reduces to 4. 9 times 4 is 36. I get y squared over 36. And 36 divided by 36 is 1. So the major is x equals 2. The minor is y equals 6 because we took the square root of both of those. My center is at 0, 0. In the x direction, I go 2 and 2. In the y direction, I go 6 and 6. Whoa, that's a very narrow ellipse. Probably your ellipse will look better than mine. That's okay. All right. And then this is in general form. I know it's going to be a linear equation. So it's x plus y equals 7. So I subtract the x, and y equals negative x plus 7. So this is in graphing form. Y equals mx plus b. So my b value is 7. I see here what's happening. And my slope is negative 1. Negative 1. Negative 1. Negative 1. I see why I wanted to put this one on this slide. Because what happens when you graph it? Null set, no solutions. They don't ever touch. All right, there we go. Finished out our last lesson for the year on conic sections. I felt that this was maybe the lesson that carries over to pre-calc the best and will help you get ready for next year for college. Every pre-calc, every calc, every algebra 2 book I've ever seen covers conical sections. There's so much good math in it. So page 644 to 647, so 646 to 647. I'm opening my book here to give you what the homework is going to be. 1 to 6, 10 to 16. Okay. Numbers 1 to 6 and 10 and 11. How about that? We'll cut off 12 to 16. All right, 1 to 6 and 10 to 11. That's your homework. Thank you so much.